Hey everyone, notes 4.1 are on Pythagorean Theorem. And in order to be able to do the Pythagorean Theorem, the first thing we need to do is be able to solve equations with squares in them. So just like the inverse of adding is subtracting and the inverse of multiplication is division, the inverse of squaring is square rooting. And that's really important. That's really going to help us out as we're trying to solve these equations. So if you look at our first example, it's x squared equals 64. So to get rid of that square, we have to do the opposite of squaring, which is square rooting. So the square root and the square on the left side are going to cancel each other out. So the x is alone, and that's our goal. Our goal is to get that x alone. So now I need to take the square root of 16. And the square root of 16 is 4. Be careful. Don't tell me that the square root of 16 is 8. The reason that does not work is because you're accidentally dividing by 2 when you're square rooting here, but that's not what we do when we square root. The square root of 16 is 4 because 4 times 4 gives us 16. If I were to do 4 times 4, I would get 16. If I were to do 8 times 8, I'd get 64, which is incorrect. So when you square root, you're looking for what number multiplied by itself gives us this number. Now, if you're not sure, you can also use the calculator. So here I would use the square root button right here, type in 16, and the square root of 16 is for sure 4. In this next example, x squared equals 9, the opposite of squaring is square rooting, so that will get rid of the square, so I get an x left over, and the square root of 9 is 3 because 3 times 3 is 9. Let's double check. There we go, square root of 9 is for sure 3. Now, in our last example, it says x squared equals 24, and the opposite of squaring is square rooting. So again, I'm going to square root both sides, and I end up getting x equals. Now, there is no integer that when I multiply it by itself gives me 24. 4 times 4 is 16. 5 times 5 is 25, so our answer has to be a decimal. So I need to type this into my calculator to figure out exactly how much it's going to be, and we'll round it to the nearest tenth. So here I'll put the square root of 24, and I end up getting 4.898979486. So when I round that to the nearest tenth, I get approximately, so here I look at the 8, there's a 9 that comes after it, so that 8 bumps up to a 9, so my answer is 4.9. And that's how you solve equations that have squares in them. That's going to help us out when we actually use Pythagorean theorem. So now we need to talk about the definition of a right triangle, because we use Pythagorean theorem with right triangles. So a right triangle is literally what it says, a triangle with a right angle. Now, for the drawing of our right triangle, show it's a right triangle by putting this box in the corner right here. So if you look right here, we have this, we have our right angle right here. The side that is across from the right angle, the side that does not touch the right angle is called side C, and side C is called the hypotenuse. And then the other sides are called sides A and B, and it doesn't matter. I could put the A here or in the B here, or I could put the B here and the A here. It does not matter. What matters is that C is across from that right angle, and then you can place the A and the B in any other spot. And A and B are called the legs. Now be careful. Sometimes your right triangles won't look exactly like the last example that I just showed you. So like let's say for example here we have our right angle here. That means that this is side C, which means that these are A and B. So always find where C is first, and then after that you can place A and B. So this right here, our right angle is here, so this is side C, this is A, this is B. Okay, last example, our right angle is here, so this is C, which makes these A and B. All right, and in order for a triangle to be a right triangle, it has to satisfy the following equation. And that equation is a squared plus b squared is equal to c squared. And this is called the Pythagorean theorem. So find the missing sides in each of the following right triangles. If necessary, round to the nearest hundredth. So pay very close attention to how we're going to do each one of these questions. In this first question, we always figure out which one of these sides is C first. So if you see here, the right angle is down in the bottom right-hand corner. So the side across from it is this C right here. And then we can place A and B. I can say that this is A and that this is B. Or I could swap them and say that this is A and that this is B. It doesn't really matter. Again, what matters is that you place the C across from that right angle. Now we're going to use the formula for Pythagorean theorem, and that says a squared plus b squared equals c squared. So here we know that this a is equal to 9. So I'm going to replace the a with 9. So I'm going to say 9, but 9 has to be squared, plus then we know that this b right here is equal to 12. So I'm going to replace the b with 12, but I have to square it still. And that's going to equal, and then here we don't know what c is. It's x. So we're going to replace the c with x, or we could just leave it as c. It doesn't really matter. And this is what we want to solve for. Careful now, for this next part, we do not want to add 9 and 12 together because according to BEDMAS, we always do our exponents first before we do our addition. So when I do 9 squared, I get 81. Careful, it's not 18. 9 squared is 81 because 9 times 9 is 81. And then 12 squared means 12 times 12, which is 144. And then I can't do anything with this x squared, so all I do is just copy it down on this line right here. Okay? Now, when I add 81 and 144 together, if I type that into my calculator, I would end up getting 225. So 225 is equal to x squared. Again, there's nothing I can do with this x squared yet, so I just bring it down. Now I can get rid of that square. Now the only time I can do square rooting, or the only time I can get rid of that squared, is if x squared right here is by itself on one side and the other side has only a single number. So for example, over here, I could not square root yet because we don't have a single number here. For example, here I cannot square root yet because I don't have a single number over here. On this part right here, I can square root because I have a single number over here. So let's go ahead and square root. Whatever I do to one side, I have to do to the other side. And the square root and the square will cancel each other out, so I end up getting x equals. Now let's figure out here, what is the square root of 25? So here I just type in the square root of 225. Sorry, I meant to say 225. And the square root of 225 is equal to 15. So the answer to x here is 15. And I'm good to go with this question. Let's look at this next one right here. This one's a little bit trickier. So this time, I still want to place the c first. So here's my right angle, which means that 10 is c. And then that tells us that either x could be a, or 6 could be a. It doesn't matter, but since I put x is a, then 6 is b. So let's go ahead and write Pythagorean theorem down. A squared plus b squared equals c squared. This one's a little bit different because this time I don't know what this a value is. I don't know what the leg is, and I do know the hypotenuse. I'm told the c value. So here for a, I'm going to say x, but I have to square it, plus b here, I'm going to say 6 because we know that b is 6. So I'm going to say 6 squared is equal to c squared here is 10. So we know that c is 10. So equals 10, but I have to square that. Now at this point in time, I am not allowed to square root because the x squared is not alone on this side over here. So instead, I'm going to square all of these values here to make this easier for me. So 6 squared is 36 because 6 times 6 is 36. X squared, I can't do anything with it, so I just copy it down. And this is going to equal, now 10 squared means 10 times 10, which is 100. I'm still not allowed to square root yet because the x squared is not alone on one side. I have this 36 and I don't want this 36, so I want to get rid of this 36. And how do I get rid of this 36? You do the opposite of adding, which is subtracting. So I'm going to subtract 36 on this side, but whatever I do to one side, I do to the other side. Then when I do it on the other side, 100 minus 36 is equal to 64. And then this 36 canceled out, but I still have this x squared left over. So I'm going to bring down this x squared. Now that x squared is completely alone and I have a single number on the other side. So now I'm allowed to square root. So I'm going to square root both sides right here. And the square and the square root will cancel out here. So I'll get x equals, and then the square root of 64 means what number times itself gives me 64. If I do the square root of 64 here, I end up getting 8. This is also just a number that I know off the top of my head, which if it's not something you know off the top of your head right now, that's okay. These are some numbers that you're going to want to probably memorize, okay, because it's going to make things a little bit easier. So here, our missing value for x is 8. Okay, in this next example, we look for the right angle, and we see it's right here, so that tells us that the 24 is the C value. This is the hypotenuse. And that means that I can choose which one of these numbers can be A and which one of these numbers can be B. So I'm going to say that this is A and that 6 is equal to B, and it doesn't matter. Either way is fine. As long as you say that that 24 is the C. So Pythagorean theorem says a squared plus b squared equals c squared. For a, we said that a is x, so we'll put in x here. You can leave it as a as well if you want. So, but I have to square it, right? Plus, and then here the 6 is b. So I'm going to say 6 squared is equal to, and then here we know that 24 is c, so instead of c, I'm going to replace this with 24, and I'm going to say 24 squared. Quick note, I cannot square root here because the 6 squared and the 24 squared, I don't know what those numbers are, and the x squared is not by itself on one side. So right here, I'm just going to bring down this x squared. There's nothing I can do with it. I do know that I can square 6, and 6 squared is 36 because 6 times 6 is 36. And then I'm going to say equals, and then be careful with this 24. 24 squared is not 48, even though some people might instinctually feel like that's what they need to do. 24 squared means 24 times 24. So 24 squared is 576, or we could just do 24 times 24. Either way, we still get 576. So now I need to get this x squared alone. I still cannot square root because the x squared is not alone. So I need to get rid of this plus 36. And to get rid of a positive 36, I would have to subtract 36. So minus 36 from both sides right here. And I end up getting x squared on this side, and that's equal to, and then when I do 576 minus 36, I end up getting 540. Now that the x squared is alone and there's only one number on the other side, I am allowed to square root. So let's square root right here. And when I take the square root of x squared, the x and the squared cancel each other out. So I get x equals, and then I have to figure out the square root of 540 in my calculator. Let's go ahead and do that. And I end up getting 23.2379008. And just a heads up, this isn't the end of the number. There's more to the number, but the number goes on forever, and we cannot display that on the screen, so it chops it off at a certain point in time. And then the directions here say to round to the nearest hundredth. So when I round this to the nearest hundredth, I'm going to look at the 3 is the hundredth place. The 7 comes after the 3, so that tells us to bump this 3 up to a 4. So my answer here is 23.24. Okay, in our last example, the first thing we want to do is identify what the C value is. So here we have our right angle here. So this time the C value is x. So our hypotenuse is what we are trying to figure out. For A and B, it does not matter. I'll say this is A and I'll say this is B. If you want to swap them around, that totally works as well. So we'll say A squared plus B squared equals C squared. So here A is 7, so I'll do 7 squared, right? See how we said that A was 7 here? So I just substitute 7 in for A here. And then B is 3, so I'll say plus 3 squared is equal to x squared, because here we say that x is C. Again, you can also just put in, you can just leave it as C if you want. So now let's go ahead and evaluate what these answers are. I cannot square root this yet because even though the x squared is alone, I don't have a single number on this side. So let's go ahead and evaluate. So 7 squared means 7 times 7, which is 49, plus 3 squared means 3 times 3, which is 9. and that's going to equal x squared right here. I still cannot square root yet because this is not a single value. So let's go ahead and figure out what 49 plus 9 is. So 49 plus 9, when I add them together, is 58. Notice this time I add them together because they're on the same side. In this example, I have to subtract the 36 because the 36 and the 100 are on opposite sides, so I cannot add them together. Copy down the x squared, then I can square root both sides right here. And the square root of x squared, these will cancel out, so I end up getting just x. And then for the square root of 58, let's figure out what this is approximately. And again, we're going to round to the nearest hundredth. So I end up getting this whole long number here. And so this 1 right here is the hundredths place. So this 5 tells us that 1 should bump up to a 2. So x is approximately equal to 7.62. And that's it for this video. If you have any questions, let me know. Otherwise, I'll see you in class. Bye.